Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematics class is more about mathematizing, not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental mathematical relationships. That math class could be less like it has been for so many of us and more like mathematicians working together. We answer the question, if not algorithms, then what?
Yeah, so for the last 2 weeks, we have been talking about an important series about multiplication facts.
Dun, dun, dun.
We shared some clarification around the words memorization, automaticity, and fluency. And then
Very
last
important.
week in episode 35, we described some things that teachers often do in the name of helping kids learn the multiplication facts that actually don't work like we want them to because they're focused on either learning the facts in isolation or using shame to motivate or really emphasizing speed.
Yep.
In today's episode, we want to unpack some ideas about what we would recommend as you're working with students and their facts. This episode is definitely for parents and teachers alike.
Because remember that the issue here isn't whether students should own their facts. We
Right.
absolutely want students to own the multiplication facts, but how this owning is achieved by rote drill and practice or by focusing on relationships.
Yeah.
Remember, we quoted elementary mathematics researcher Kathy Fosno as she talks about helping students learn the facts by developing relationships because in that way, the facts become automatic. But the relationships, the heart of mathematics, are not sacrificed. And we totally agree with that. We have a super cool, helpful download for you for this episode. So check out the show notes or keep listening and we'll give you the link at the end of this episode.
Yeah. So, Pam, I like it when you talk about taking the long view. And I wanted to mention that one of the most important things that I think I did as a third grade teacher in regard to facts was to advocate for starting the year with multiplication rather than the pretty traditional few weeks of place value, then addition and subtraction. And because we started with multiplication, we were able to give students a lot of exposure and experience with activities and routines really early on and help them make sense of what multiplication is before we started moving towards building more with the facts.
And to be clear, it's not like you skipped place value addition subtraction.
No.
It's just that you started with kind of rudimentary, a lot of skip counting multiplication, but
Sure.
because you started with it, then you had the whole year to mess with it. And I'm a little curious, did you do the same thing in 4th and 5th grade? Like, so let's start with it off the bat, give you lots of time,
Yeah.
that long view over the whole year. Yeah?
Yeah.
Okay, cool. So let's talk about what you did do, like what to do. What in the world then did you do all year long to help students learn relationships and develop their multiplicative thinking so that the multiplication facts were a great byproduct?
Well, so again, I started the year with multiplication. And
Right.
if that's not an option because your district or school has a mandated scope or sequence that you feel like you can mess with, you can still introduce some multiplicative relationships in small doses throughout your week. And I think I've mentioned before that 2/3 of the math time that I had was core content that we followed a scope and sequence. And then the other 1/3 was a mixture of all kinds of things. And so if I wasn't able to help shape the order of material, I think I would have done some things more consistently in that 1/3 chunk of time. Because the amount of time we give kids to become reasoners about facts really matters.
Absolutely. So order matters
Yeah.
when we think about the order of your sort of school year. That matters.
Yes.
Order also matters when we think about how to build the facts because we can base some facts off of others. And so we want to think about the order, like Kim just said, the order that you teach throughout the year, but also the order in which you work on the facts. So we often see a lot of teachers and some of the things that we talked about that we're not crazy about in the last episode. So if you haven't listened to the last episode, we highly recommend that you go catch that because a lot of those things that we don't recommend and we see a lot of places typically start with like times 1, times 2, maybe times 0 first, and then times 1, times 2, times 3, times 4, like they go in order, right? But we suggest that it's much more beneficial to explore these relationships in maybe a different order. Like what are the relationships that would be helpful for students to think about? So Ready? Let's experience that for you listeners as learners. So we're gonna actually experience this a little bit. Here we go.
Okay, so today you're going to be the person, right?
Okay.
I'm going to give you
All
math. So
right,
just
cool, cool.
I'm going to give you some problems. Will you just talk out your thinking a little bit?
Yeah, absolutely.
Okay,
Yep.
so today you're going to think about 23s.
23.
23,
Okay.
is that good?
Hey, so since I'm talking about my thinking, I'm going to tell you, I just picked up a pen and I wrote down the number 23. So that's what's on my paper right now
I
is
grabbed a
23.
pencil.
I'm a pen person. Kim's a pencil person. It's
Okay.
all good. Okay.
All right. 23. All right. What
Okay.
is 2 times 23?
Two 23s is 46 because I double the 20, double the 3, and that's 46. So,
Okay.
okay.
46. What is 4 times 23?
So I'm going to be lazy and just double the 2, the 46. So if I double 46, I'm going to double 40. That's 80. Double 6 is 12. So that's 92. I'm going to check that by thinking about double 50. Double 50 is 100, but I need to take off the extra 4 twice. And that's 92. Yep. So 4 23s is 92. Mm-hmm.
Okay, that was pretty quick. So 2 23s is 46.
Mm-hmm.
And double that for 4 23s is double 46, which is 92.
Yep.
Okay.
Yep.
Let me ask you 8 times 23.
Oh, nice, because I can work off the 4. Okay, so if I know that 4 23s is 92, then 8 of them is going to be double that, and double 92, I'm just going to double the 90 to get 180, and double the 2, 4, so 184.
Okay.
Okay.
All right. What about 10 times 23?
Let's see, I know this thing in our place value system where I can think about 23 tens, and so that's 230, 23 tens.
Okay. 230. What about
I guess I
5?
should say really that's the commutative property that I just used to think
Oh,
something.
yeah. Because
Yeah,
I asked you 10 times 23, but you really
right.
thought about 23 tens.
Yeah,
Yeah.
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 So commutative property, okay?
Okay. So 10 times 23 was 230. What if I asked you 5 times 23?
Oh, nice order, because I can just totally work off the 10. So if 10 23s is 230, then 5 is half of 10. And so half of 230 is 115. Yep.
Cool.
Okay.
All right. So you just thought about 10 times 23.
Mm-hmm.
Okay.
230.
Yep. And so what is 9 times 23?
Oh, nice. Let's see. So that's just going to be 23 less than 230. And so 230 minus 20 is 210. Minus 3 is 207. So it'd be 207 is 9 23s. It's 23 less than 10 23s. Mm-hmm.
Nice.
Okay. Thank
That's
you.
it.
All
Well
right.
done.
Cool. 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 So let's look at those relationships that you just sort of emphasized. Yeah. Like you asked me for 2 of them
Mhm,
to get 4 of them
mhm.
to get 8 of them. And I could just sort of double, double, double.
Yep.
Yo, we want kids to know that they can find 8 times anything by double, doubling. And they can find 4 times anything just by double, doubling. That's a powerful relationship that kids could use. And it helps them sort of begin to think about doubles. And that's a multiplicative way of thinking. Then you gave me 10, which if we have this commutative property and we can learn the pattern in our base 10 place system, that we can think about that 0 and how I'm thinking about 23 tens. Anyway, so 10 is easy to get right off the bat. And then you asked me 5 right after that. Oh, brilliant, because I can just cut it in half since 5 is half of 10. Okay, totally cool. Then I don't know, listeners, if you noticed, but then Kim said, and 10 again, in some way, you asked me for 10 again,
Yeah.
which then pulls up that 10, and then you asked me for 9. So that's a way to sort of nudge, oh, you have that 10. Can you use that to help you think about 9? I mean, you didn't say, all right, now use the 10.
Right.
Here's what you
Right.
do. Step 1, step 2. You just like mentioned, oh, yeah, what was that 10 again? Okay, right. Now 9. And then I'm sort of nudged. That's the 10 is poking in my brain. Pinging is the word I want. Pinging in my brain. And so then I'm tempted to sort of use it to find the 9.
Right.
What a great set of relationships. So let's continue to parse that out. Y'all, do I need to know my 23s? Like, we're talking about single digit facts. These episodes we're working on right now is all about single digit facts or know your multiplication facts. Or 20 is 23. Is that one of the facts that's on your list? Not typically, right? Typically we ask kids to know the single digit facts, or 10 by 10, or maybe 15 up to 15 by 15, even though we think that's a little much. So 23 is not on that list, but it's about the relationships.
Sure.
So those relationships that Kim just had me use, those are important. So can we use those same relationships to figure out single digit facts? Absolutely. We want kids to be able to think about sevens Could they think about 8 times 7 in the same way that I just thought about 8 times 23? Can they double 7 to get 14? Oh, I should have asked you that, Kim. Kim,
Yeah.
if double 7's 14, what's 4 times 7?
Double 14, which would be 28.
And then what's 8 times 7?
Double again, right? Which is double 28, and that's 56.
Yeah. And if you say to yourself right now, my kids can't double 56, I can't even, or excuse me, double 28, I can't even double 28. Then what we recommend is that you start doubling with them, double yourself. Like that's a thing to do, is just to start doubling with kids. They get better and better at doubling, and then they can. Then that's a relationship that they can use. So let's just, again, reiterate. So 2, 4, 8, great relationships. 10 to get to 9 or 10 to get to 5, great relationships. So there's one that we didn't do just for fun. We'll do it now. What if I wanted to ask something like, Kim, I'm going to ask you to think about 31s.
Oh, great. Okay.
Again, not a number that's like typically
Right.
a single digit fact, right? So we're going to kind of exemplify it with a bigger number and then back up to single digit facts.
Okay.
So 31,
Mhm.
what's 3 times 31?
Okay, 3 times 31. That's I'm thinking about 3 times 30, which is 90, and 3 times 1 is 3, so that's going to be 93.
Totally cool. And that wasn't too bad, right? You
Right.
could get
Right.
skip right. You didn't have to double it and add one more. You could totally just jump right to 3 times 31. So if 3 times 31 is 93, 3 times 31 is 93, what's 6 times 31?
There's that doubling again, right? If three
Mm-hmm.
31s is 93, then now I want 6 31s. That's double the
Mm-hmm.
number of 31s. So I can double 90 and double 3 and get 186.
Bam, right? And
Yeah.
so you just like thought about 6 times 31 using 3 times 31.
Yeah.
Now, could you have thought about 6 times 30 and 6 times 1?
Sure. But I already
Absolutely.
had the 3 groups.
So why not use it, right? And then we could kind of connect that to single digits.
Yeah.
So, for example, Kim, I'll keep going. What's 3 times 7,
3 times 7 is 21.
right? So then what's 6 times 7?
Ooh, that's pretty commonly missed fact. So
Mm-hmm.
3, in fact, my son the other day was thinking about 6 times 7.
Ah.
And so 3 times 7 is 21. I can double that to get 42.
And check out how easy 21 is to double, right? I
Yeah.
mean, 21, if you could double it all, you could double 21. So that is my favorite relationship to get that most missed fact of 6 times 7. What was your kid? How was he thinking about it?
Actually, it wasn't doubling. He thought he was messing with square numbers, and he was thinking about 6 times 6 and added another 6.
To get 7 sixes,
Yeah.
to get 6 times 7.
Yeah.
That's a fine relationship, and we would love kids to recognize that 6 times 6 is related to 6 times 7. Absolutely. We also want them to own this idea that they can
Sure.
double from 3 to get 6.
Yeah.
Totally cool. Let's keep going. So if 6 times 7 is 42, what's 12 times 7?
Double again. So I know 6 sevens. So to get 12 sevens, then I can just double the 42 from the 6 sevens and get 84.
And now you have 12 times 7. So, y'all, it can be really helpful to have these relationships. We're not suggesting that kids laboriously refigure these relationships ad infinitum. The older they get, the more experience they get. But the more experience they get with these relationships, they actually go quite quickly.
Yeah.
In fact, I'm going to suggest that kids might run into 12 times 7 and go, let's see. And just in their brains go, I know it's twice 40, 84. And it can be that fast. It can be fast enough for them to go, I know it's twice 40 to 84. Like they can just think about the 6 times 7 to get the 12 times 7 in it. And that can be a way that not only can that be a way for students to do that, that is the way that mathematicians pull up multiplication facts that they don't just cold remember. That and often that is true, that they don't just cold remember, but that they think of some quick relationship that they know, they figure it doesn't bog them down in the work that they're doing, and they keep going. But even more importantly, they're building multiplicative relationships as they go. That's why they're able to do it, is because they own those relationships.
Yeah. Can I bring up another point?
Yeah.
We also think about language as well. And I think I've heard both of us alternate our language between saying things like 2 eighths and 4 eighths, and then later alternated into saying 2 times 8 and 4 times 8.
Mm-hmm.
And we do a lot of work with doubling and then bring in the language and the recording of the time symbol. because kids can be super freaked out by the notation or having heard maybe that multiplication is hard. So instead,
Mhm.
we advocate for having them experience multiplication and then bring in the vocabulary and the symbols.
Yeah, in fact, when you bring that up, I just thought of a little guy I was working with the other day. We were just chatting about some mathy things, and he's young, and so we were doing some addition, subtraction stuff, and he looked at me with these big eyes, and he goes, "But I can do multiplication
Mm.
because like this it's this thing, right?
Yeah.
It's like I can do multiplication." And then we'd been working with some fairly big numbers, and he's like, "I know 2 times 4." I
Mhm.
was like, "Okay, good for you. It's 2 4s." Like if he really understood that 2 times 4 wasn't this. Um, Crazy thing, it was just 2 4s, I don't think he would have been quite as impressed with himself that he knew 2 times 4,
Yeah.
because it was just sort of this outside crazy big impressive thing. So we like to make it much more about the meaning of what's happening, then bring in the language like you said, and then bring in the notation last. And so the kids are like, oh yeah, that's what we've been doing, and now this is what it looks like on paper. Okay, totally cool, no
Yeah.
problem. And that fits, Kim, what you just talked about with vocabulary just in time. We've talked about that before in the podcast, where we want to give vocabulary just in time when students need it. It's a great example of that. Hey, it's also reminding me really quick of a story when my daughter Abby was in 5th grade. I'm pretty sure she had to do some multiplication time tests, and at that point we were living within walking distance of the school, kinda. And so she wanted to walk to school, and I said, "I will walk to school with you if." Because then I had to walk back home, right? Then walk back to school and then walk back home with her. So I just doing double the walking. I said, if we can like do some multiplication fact stuff on the way, because my kids every once in a while they're great at math. They mathematize with the best of them, but sometimes doing it with your mom, is not like your ideal thing to do.
You don't say.
Maybe she's an artist. She wanted to talk about other things. And so she agreed. And so as we were walking, I would literally do kind of what you did. I would say, okay, let's talk about and pick a random fact. Nines. Let's talk about nines. Hey, Abby, what's 2 times 9? What's 4 times 9? What's 8 times 9? Hey, what was 2 times 9 again? What's 3 times 9? Cool. What's 10 times 9? What's 9 times 9?
Mhm.
What was 10 times 9 again? What's 11 times 9?
Yeah.
What's 12 times 9? And then other times I might have gone, what's 10 times 9? What's 5 times 9? Well, 5 times 9 is that. What's 6 times 9?
Right.
That's really cool. Well, if that's 6 times 9, what's 7 times 9? Or I might have gone, what's 2 times 9? What's 3 times 9? What's 6 times 9? Oh, cool. Then now that you have 6 times 9, what's 7 times? And I'm
Yeah.
using those relationships, but we just back and forth in the air as we were walking. So parents, we suggest you could do this kind of thing in the car. Now, to make it fun, have the kid talk about what they're thinking about and you share what you're thinking about. That makes it much more fun than just don't make it be this like, I'm just going to drill you right now. It's not about drill. It's about using the relationships. It's about talking about the connections in your head.
Yeah. That's great. And I think really helpful to spend a lot of time talking about those relationships instead of making it be something that you do once and then expect that they know. Right.
Well put. Well, yes. Good. Remember,
Yeah.
it's not about, okay, we've done your sixes in the car last Thursday. You
Yeah.
should know them. No. Like it's like building these relationships and then exposure and doing them, having lots of fun doing them often.
Yeah.
Sure. Yep.
Okay, so today we shared just a few ideas about how to work with students on their multiplication facts, right? But you're
Hmm.
really going to want to listen in next week when we share the final episode in the series and give you some great routines, some games, and ways to continue building relationship for all students.
Yeah, you are not going to want to miss that one. So stay tuned for next week's episode. Hey, we promised you a download with some really helpful things. The download has helpful problem strings for single digit facts, like the strings that Kim and I did today live on the podcast. So if you'd like that handy dandy download, you can get it on the show notes or go to mathisfigureoutable.com/facts PS. So mathisfigureoutable.com/facts PS, FACTS PS.
Yeah, we would absolutely love it if you join us on Math Strat Chat on Facebook, Twitter, or Instagram on Wednesday evenings, where we explore problems with the whole world.
Please share with your friends and your colleagues and give us a rating and a review so that more people can find the podcast. So, if you're interested to learn more mathematics and you want to help yourself and your students develop as mathematicians, then don't miss the Math is Figureoutable podcast, because math is figureoutable.